Docker best practices. Running containers is easy. Building production-ready containers requires discipline. Best practices improve security, performance, and reliability. Professional teams follow standardized Docker guidelines. Lesson objectives. Learn Docker design principles. Build efficient container images. Improve security and reliability. Understand production-ready practices. Avoid common beginner mistakes. Why best practices matter. Poor Docker practices can cause security risks, large images, slow deployments, operational complexity, increased costs. Best practices reduce long-term problems. One container, one responsibility. Docker principle. One container equals one purpose. Examples. Jinx container. MySQL container. Redis container. Avoid combining multiple services into a single container. Benefits of single responsibility. Easier maintenance. Simpler troubleshooting. Better scalability. Improved reliability. Easier updates. Small containers are easier to manage. Use official images. Prefer official images such as Jinx, MySQL, Postgres, Redis, Node. Official images are maintained and regularly updated. Keep images small. Smaller images provide faster downloads, faster deployments, lower storage usage, reduced attack surface. Smaller is usually better. Choose lightweight base images instead of Ubuntu. Consider Alpine. Benefits. Smaller size. Faster pulls. Fewer packages. Better security. Avoid unnecessary packages. Install only what is needed. Avoid editors, debug tools, and used utilities. Every package increases image size and risk. Understanding multi-stage builds. Build stage. Compile application. Copy required files. Runtime image. Results in smaller production images. Benefits of multi-stage builds. Smaller images. Cleaner images. Better security. Faster deployments. Widely used in modern Docker projects. Use explicit image versions. Avoid Jinx latest. Prefer Jinx 1.25. Explicit versions improve consistency. Why avoid latest tags? Development, testing, production, unexpected image change. Version pinning improves predictability. Externalize configuration. Configuration examples. Database hosts. Environment names. Service URLs. Configuration should not be hard-coded into images. Use environment variables. Examples. db_host equals database. app_env equals production. Benefits. Flexible deployments. Easier configuration. Better portability. Never store secrets in images. Never embed passwords, API keys, tokens, certificates. Secrets should be managed separately. Run containers as non-root users. Benefits. Reduced privileges. Improved security. Lower risk. Least privilege is a security best practice. Limit exposed ports. Good practice. Front-end public. Back-end internal. Database private. Expose only required services. Use volumes for persistent data. Store important data in Docker volumes. Benefits. Data persistence. Easier backups. Safer upgrades. Keep containers stateless. Stateless applications are easier to scale, replace, recover. Application state should live outside containers. Use health checks. Healthy container. Accept traffic. Unhealthy container. Investigate problem. Health checks improve reliability. Monitor resource usage. Monitor CPU, memory, storage, network. Monitoring helps identify issues early. Apply resource limits. Examples: CPU S equals 1. M512M. Resource limits protect system stability. Log important events. Capture. Startup events. Errors. Warnings. Key operations. Good logs simplify troubleshooting. Use meaningful container names. Avoid. Container 123. Prefer. Frontend. Backend. MySQL. Clear names improve administration. Use Docker Compose. Benefits. Centralized configuration. Easier management. Service discovery. Simplified deployment. Ideal for multi-container applications. Keep Docker updated. Updates provide security fixes, bug fixes, performance improvements. Regular updates improve reliability. Scan images for vulnerabilities. Workflow. Build. Scan. Fix. Deploy. Security should be part of every deployment. Document everything. Documentation should include purpose, ports, volumes, environment variables, dependencies. Documentation improves collaboration. Automate repetitive tasks. Automate. Builds. Tests. Deployments. Automation improves consistency and speed. Real-world production example. Production application uses. Official images. Multi-stage builds. Environment variables. Volumes. Monitoring. Resource limits. Result: stable and reliable deployments. Common beginner mistakes. Using latest tags everywhere. Storing secrets in images. Running as root. Building oversized images. Ignoring monitoring. Avoid these mistakes whenever possible. Docker Best Practices Checklist. Official images. Small images. Version tags. Non-root users. Protected secrets. Volumes for data. Resource limits. Monitoring enabled. Health checks. Documentation. Benefits of following best practices. Better security. Improved reliability. Easier scaling. Faster deployments. Simpler maintenance. Professional environments depend on these practices. Interview question. Question: why is it considered a Docker best practice to keep containers focused on a single responsibility? Answer: single-purpose containers are easier to maintain, scale, troubleshoot, secure, and update, making applications more reliable and manageable. Key takeaways and lesson summary. Follow Docker design principles. Keep images small and secure. Use official images and version tags. Protect secrets and run as non-root users. Monitor, document, and automate. Best practices create production-ready Docker environments.